So today we're in 4.3 equivalent fractions, forming equivalent fractions, looking at equivalent fractions to see if they truly are equivalent. Lots of different perspectives we're taking today. The first thing we're going to do, and you're going to see this in your homework tonight, you would see this type of format on a quiz and a test too, but it says to write two fractions that are equivalent to the fraction 8/12. All right, well, in order to write an equivalent fraction, you must either divide top and bottom by the same number or multiply top and bottom by the same number. You could divide both, multiply both, any combination of the two, as long as you're multiplying or dividing top and bottom by the same number. So let me ask you this. Can you reduce 8/12? Yes. Yeah, you can reduce it by what? 2. By 2? And by 4. So that's how I could create my two equivalent fractions, or I could multiply by any number as long as it's the same number top and bottom. Now, I want to keep it simple though. 2, 3, 4, 5. I'm not going to multiply by 22, okay, and make this more complicated than it needs to be. So in the first one, I divided the first fraction by 2 and multiplied the second fraction by 2. Now, if the fraction that you're writing the equivalent for cannot be reduced, then you would just multiply both of them. So on your homework tonight, you'll have a fraction in a question that maybe cannot be reduced, so you just multiply each one by like a different number. Maybe you multiply the first one by 2 and the second one by 3, or something like that. All right, now on your second fraction, 4/16, I want you to create two equivalent fractions. All of your answers are going to be different. Some of you may divide, some of you may multiply. Any combination of the two. Just make sure you're using the same number top and bottom. So what did we do? What number did you use? Divide by 4. What else? Divide by 2. Anybody multiply? Multiply by 2, by 3. Anybody do any other numbers multiply?
10.
Okay, 10. That's still an easy one. All right, so there's a lot of different possibilities. Here's what I need you to make sure that you do. Because there isn't going to be, basically set numbers, you must make sure that you show me what you're dividing and multiplying by. I'm not going to guess. When I'm grading 110 quizzes, I don't want to have to look at your equivalent fractions and try to guess at what you divided or multiplied by. Okay? So you need to make sure you write that step. All right, any questions on equivalent fractions? In example 2, we're simplifying fractions. So you have a fraction, say 12/30. Write that one in your notes, 12/30. And you need to simplify it down into simplest form, basically so it cannot be reduced anymore. There are multiple numbers that I could reduce by. What's a number I could reduce by?
3.
6, 3. What's another number I could reduce by?
8.
2. 2 is another number. Okay, so let's say I reduce by 3 and I get 4/10. Is this my final answer?
No.
No, I have to keep reducing again until I get down to simplest form. So here's my advice, okay, and what the book stresses that we do is we find the largest number that goes into both numbers, because then I only have to reduce one time to get to simplest form. And we said that already at 6, okay? So if I had reduced by 6 from the beginning, I would have got to 2/5 in just one step. Okay, so try to find that GCF. Now, if it's just a massive fraction, just start off by dividing by 2 or 3 and knock it down until it gets to a point where you can just go ahead and reduce it. Don't spend, 20 minutes trying to find the GCF. Does that make sense? All right, so go ahead and reduce the next two fractions, 8/12 and 15/21. I do want you to show what you're dividing by. I want to see that you can divide by the GCF. It's not something that I would necessarily mark off from or on a quiz or a test, but it's just good practice to try to find the largest number that goes into both of them. All right, so 8/12, what did you divide by?
4.
Yeah, divide by 4. So if you divided by 2, you had to do 2 steps. You should have divided by 4. And 15 over 21, divided by 3. All right, now, another thing I want to point out is this. Yesterday we learned about numbers being relatively prime. What does it mean when numbers are relatively prime?
They don't have relative.
They have what?
Only divisible by 1.
Yes, they have no common factors besides a 1. So, when a fraction is in simplest form, I would also say that those numbers, the numerator and denominator, are relatively prime. Here's what it means. They share no common factors. There's no number that can evenly go into both of them. Do you see that? So, out here, 12 and 30, these numbers are not relatively prime because they shared a common factor. And what do we find? 3, 2, 6. But when we get down to simplest form, is there a common factor between 2 and 3 besides 1? No, there's no other common factor. Do you see the connection? When a fraction is in simplest form, I would say that the numerator and denominator are relatively prime numbers. You see that? It's the same concept. They share no common factors. All right, you need to be able to make that connection. In example 3, they give us a scenario and they want us to create a fraction from the scenario. You have one question like this on your homework tonight. Okay, so in your book, it gives you a map of the United States. Can everybody form a picture of a map of the United States in our head? Okay, let's go ahead and just throw one up there. All right, so a map of the United States. We see it. Can y'all see that okay? All right, so here's what your book says. Your book says that there are 48, do y'all have a word that that's just always hard for you to say? Like no matter what, is there a word? Okay, so my word is this word. It's contiguous. Yes, contiguous. So contiguous, I know, it's a really strange word, and I struggle with the pronunciation. You'd think as many times as I've taught this lesson, I would get it. But here's what contiguous means. It means that they are connected. So the United States has 48 contiguous states. Which 2 are not connected? Alaska and Hawaii. Okay? But out of those 48 contiguous states, it's saying that 21 of them, and I'm just going to draw a rough outline, 21 of them, okay, are coastal. 21 of the states, so that's your coastline. 21 of them are coastal. So here's what it wants you to do. It wants you to form a fraction that shows the relationship between contiguous states and coastal states. All right, so let's go back over to example 3. Where did it go? I'm just going to go this way. All right, it's talking to me. Okay, in example 3, so it says, we saw the picture of the map. Of the 48 contiguous states, 21 of them are coastal states. Write a fraction in simplest form of contiguous states that are coastal states. All right, so here's what this means, and this is important that you know how to set up a fraction. Our denominator represents always the total or the whole. Okay, our denominator is the total, and our numerator, it represents the parts of the total. All right, a fraction is always set up this way. It's like the individual pieces in your numerator. So, which number do you think belongs in your denominator? 48. Which number in your numerator? 21. And now I just have to reduce it. Okay, I would divide top and bottom by what? Could I do 6? No. 6 doesn't go into 21. Can I do 7?
Yes.
Nope. 7 doesn't go into 48. I divide by 3. Out of every 16 contiguous states, 7 of them are coastal. All right, so basically I'm just taking a scenario and making a fraction out of it. What you need to remember is that your total goes in the denominator and the parts of the total go in the numerator. All right, that's the most important part from this example. Any questions? All right, example 4. In example 4 now, you guys remember monomials?
Yes.
Okay, we factored them, we found GCF with them, and now we're going to simplify them. All right, now your book tells us that we need to actually do the prime factorization of the number, but at this point, and for the purpose of simplifying a fraction, we're not going to go through all of that work. We're going to just simplify the number part. What I want you to do is use your calculators if you can't do this mental math. Now, can we all simplify 10 over 15 mental math? I would think so. However, if you want to double check your answer, use your calculator, hit the fraction button. Everybody do this. Hit the fraction button on your calculators. Okay? Now enter the fraction 10 over 15 and hit equals. It will reduce it for you. It reduces your fraction for you to what? 2/3. All right? So now, at this point, you have reduced the number part of your monomial, and now you're going to write the variables in expanded form. So for 10xy, we reduced it to 2, and we're going to multiply by x and multiply by y. We're writing the variables expanded. On the bottom, what do we have? Y squared, so it's going to be what? Y times y. Now, are there any common variable factors that I can cancel? I can cancel a y. And what am I left with on top? 2x over 3y. And that's simplest form for a monomial. So use your calculators to reduce the numbers and then write your variables in expanded form and cancel your groups. Okay? I want you to go ahead and try the second one on your own. All right, so we reduced 15 over 30 to what? 1 over 2, right? Now, times how many x's?
2.
Times how many y's? 3 y's over just 1 x. So what can I cancel? An x. What am I left with on top?
1x
Times y to the third. Now, you don't need the 1. The 1 is understood. If you put the 1 in front of the x, that's no big deal. You will not be deducted for that. X, y to the third over just 2. All right, who got that one right? Okay, good. Go ahead and do the third one now. All right, write the fraction in simplest form. So reduce the numbers, write the variables in expanded form, cancel the groups, and then rewrite your final answer. All right, so 16 over 40 reduces to what?
2/5.
2/5 times A times B over A times B. So what cancels?
1A and 1B.
A and B. So what are you left with on top? 2B, and on bottom? 5A. All right, raise your hand if you got it. Okay, you have 2 questions on your homework that basically have like an unknown part of a fraction. So it basically says this. You have 5/6 and x over 24. And they want you to find the value of x. Well, what you have to do is, you have to look, okay, from the fraction I know to the fraction I'm trying to solve for, is it getting bigger? On this side, is it getting bigger or smaller? Bigger. So I'm multiplying. What did I multiply by? To get from 6 to 24? 4. So if I multiply the bottom by 4, I have to multiply the top by 4. What's 5 times 4? 20. X equals 20.
So it's not cross multiplication.
It's not cross multiplication. It's basically like when we did proportions, the missing link. Okay, maybe you remember that from 7th grade math. That's basically what we're doing here. We're trying to find the connection between one fraction to the other. If the numbers are getting bigger, it's multiplying. If they're getting smaller, it's dividing. So look at the second fraction. I want you to try to figure out, all right, am I multiplying or dividing, and then what's the missing number between, and then try to solve for x. All right, so I'm going from 80 to x and from 192 to 12. So am I multiplying or dividing?
Dividing.
I'm dividing. I'm going from a large number down to a smaller number. And what is that number that I'm dividing by? 16. 192, if I divide by 12, I get 16. So 80 divided by 16 is what?
5.
X equals 5. All right, so you have 2 problems like this in your homework tonight where you have to just figure out on the value of x. If you understand that, that's everything you need to know for 4.3.